Hi, everybody. My name is Matt Gurwin. I'm the Chief Executive Officer of HeatX. I have our Chief Strategy Officer, Ignacio Bonell, with me. He'll be driving in. He'll be here also for the discussion purposes. So again, thank you for having us. We're HeatX is a technology and R&D company, and we're focused on magnetic caloric and magnetic induction technologies, principally on the heating side. Magnetic caloric technology has been around for a long time. The advantages of it: no fossil fuels, gas emissions, no refrigerants that we talked about this morning. The issue with magnetic caloric technology in the past has always been the very expensive materials, and actually most of the materials have been toxic in their pure form, and which drove very inefficient designs. Well, I can tell you that HeatX has figured out that combinations of affordable materials, readily available affordable materials, with very efficient designs to drive the opportunity to put this technology in place right now in 2021 and not in 2030 or 2040 or 50. This chart you'll see right here, again, we're not gonna go through the chart in detail, but what the takeaway is that you'll see our current coefficient of performances that are listed there along air-to-air heating, which are furnaces and dryers, surface, which are cooktops, and ovens, and then obviously water boilers, water heaters, that type of thing. You'll see that the current maximum temperatures in those areas, 120 degrees in air-to-air, 950 degrees in surface, that's Fahrenheit, and in the water heaters, obviously we're close to 250 degrees. And I want to point out that we are very confident in the next 12 months that those numbers will be much more improved and efficient, both on the temperature side as well as efficiency numbers. Next slide. All right, so this slide, again, the takeaway here is, DOE, and we're lucky to have Tony Boza and Ayub Momam here today. They knew the power of magnetic caloric technology, and they saw it as a 2030 type opportunity. The issue back just 5-6 years ago was there wasn't any American leadership in this technology. And I can tell you that HeatX has stepped in here, and we now have the largest patent portfolio in the heating side of magnetic caloric in the country. And we're excited to put this in place as soon as possible. We are not a manufacturer. We're someone who's going to work with partners to commercialize this around the world as quick as possible to get the greatest impact to reduce the carbon footprint in the world. And you'll note that it's always been our mantra to surround ourselves with the best people. Our advisory board people, some people know people that are listed there who have the same mission and vision as us: Carrie Duggan, Christine Harada, and Jim Saber. On this next slide, again, we're not gonna go through in detail, but you'll see that we're green technology. We have a very strong technology patent portfolio. We're clean and efficient. The numbers speak for themselves. We're scalable, we're modular, we're decentralized, and we have working prototypes that show the scalability. We have a 1.5 cooktop on the surface. We have a 2.5 kW and a 5 kW air heaters. And again, we'll get to that later. Those all been through UL field testing, and we're very excited about that. And the last thing I want to point out here: safe, affordability, and complementary. And this was mentioned. I think Tony Boza said hybrid, but our technology can be layered with other current technologies. You don't have to have all or nothing with our technology. And the bottom graph, the takeaway there is, you see how we compare to other current technologies out there, but we can go places where induction technology could not go. So that's the important takeaway there. This next slide, I'm not gonna spend any time on it. This is background on the magnetic caloric effect. This information was taken directly from DOE reports. So again, we just wanted to give for people who didn't understand it, how that works. This next slide is we're very proud of. It's from the inception of our company, through our initial third-party validations, some of the partnerships we've done. I'll highlight Next Energies that's listed there. We completed UL field testing recently on our prototypes, which was a very important milestone for our company to show the manufacturability and the safety of our products. And we're working very steadfastly right now with the University of Michigan to do a life cycle assessment, which again will be used to go into a solar impulse designation overseas, which is obviously well known globally. And the key thing here on the slide also to notice is that we spent a lot of time on air-to-air technology. We believe we know we figured that out. And recently we've done the surface and the fluids. The next 12 months is going to be a key time where we can get even more efficient. You can see where we know we're going to get in the next 12 months. We feel confident of that. And theoretically, we can go even further with help from partners like you on this call. This next slide, not spending a lot of time, we talk about this, scalable, modular, decentralized, again, complementary. That's a key thing that we just talked about. We can overlay our technology with other working technologies to work in concert with each other. And I think that's all on that slide. This slide is pretty neat. And again, we modeled average utility costs here. We used information directly from EIA to get our numbers. And you'll see right now with our current technology, in terms of utility costs, we're less expensive than gas and electricity. And again, I'm going to point out the next 12 months, we're going to get even more efficient. So this is something we're very excited about. And I hope the people on the call can see this opportunity as why this technology is something that's going to be hopefully something that's going to be important for solving some of the problems that we have out there. The next slide, and this represents the chart of the Paris Climate Agreement, and this is for heat only. We did a lot of peeling back the numbers, and 60% of all the CO2 released in the atmosphere just comes from heat. You'll see the red line is the path of no action. That would be devastating to our planet. You'll see the green line, that's the Paris Accord goals, but you got to have a technology that helps you get there. And if you see by, in the blue, which is our current, where we're at currently with our numbers, and then you see the black line, which is where we think we'll be in 12 months. We know our technology, really even by itself, if it's conservatively put out there into the world, can really help affect and solve those issues. Something I also want to point out here, which is very critical. This excludes commercial, industrial, and electrical vehicles, with our technology can also support. So, these numbers can be even better. This next slide, I just want to mention it because I think it's pretty fun. Gerald Brown back at NASA back in the 70s, they knew the power of magnetic caloric technology. It's not only something that can solve some problems on this planet, but it can solve problems on other planets. We know that for the goals for the space program, getting to Mars, Mars is -80 degrees on average temperatures, and you can't use gas, and you can't use refrigerant heat pumps, and our technology is superior electric, you can put it so to speak. So if you're going to use electric, you might as well use something that is extremely efficient, and we can help solve that issue too. We can't do this alone. That's why we're here today. We surround ourselves with great people, and we're looking forward to working with this project team and making this technology, get this out to the world as soon as possible, so that we can address the tremendous climate issues that we have in the world.